We're going to start our 9-4 notes with a warm-up. So I'm asking you to graph a circle, but the equation is not in standard form. I have x squared divided by 9 plus y squared divided by 9 equals 1. In order to make the equation into standard form, we're going to have to multiply everything by 9 so that we don't have denominators. So I'll have then x squared plus y squared equals 9. The x and y are by themselves. We don't have a quantity where there's plus or minus, so I know I haven't shifted it. My center is 0, 0. And I know that this 9 is equivalent to r squared. So that means my radius is 3. So to graph, I make the center at 0, 0. And then I need to go out 3 units all the way around to show my radius of 3. And then I draw my circle as best I can. So in math, I'm always trying to show you something we've already learned and then connect it to something new. So I really want us to reconsider this original equation. So where it has x squared divided by 9, what I want you to think about is that in the x direction, I've gone 3 units to the right and 3 units to the left. Where I have y squared over 9, I've gone 3 units up and 3 units down. So 3 units in that y direction. So I really want you to think about how in this problem the numbers are the same, but I could use different numbers for the x and the y and how that would affect what that graph looks like. So today we're working with ellipses. So an ellipse, our definition is that the sum of the distance between a point on the ellipse and the 2 foci is a constant. So here's one focus here, here's the other one over here. So in a circle, remember we just have a center. And we're looking at the distance from the center to a point on the circle is a constant. That's a radius. So now my center's right here, but I'm not using that in my definition. I'll use it for graphing, for creating a graph, but not in the actual definition. So our definition is that from this focus out to the ellipse and back to the other focus, when I take those and I add them together, I get a constant. So here's just some information about about ellipses. So we've got some different parts and things labeled. On one of them, we have this ellipse is going to be oriented so that our big axis is our x-axis, and the other one, our longer axis, our major axis, is in the y direction. So the different parts I want you to notice here are the words vertex. So on my major axis, on my big axis, I have a vertex on each end of that on my ellipse. The shorter axis, and I'll label it on this one instead, is my minor axis. And so my minor axis has co-vertices. We're kind of showing this centered at the origin, so you can see where our center would be, and I'll use that for graphing. But the focus, the foci, I have a focus over here and a focus over here. Remember those 2 foci for the definition of an ellipse? That's what I'm really going to use for graphing. So we're going to just kind of go through and list out information for both of these ellipses. And then we're really not going to worry about letters and definitions much after that. We're just going to work on getting a feel for how they graph and finding that information based on a graph. So I kind of want to show you how these look, but I'm not going to really have you memorize this stuff. So my equation is x squared over a squared plus y squared over b squared equals 1. So right now I'm looking at this first one with the horizontal major axis because they're showing that a is greater than b. My major axis is going to be my horizontal axis in this case. So since a is bigger and x is over a, then x is my horizontal axis. My major axis is going to be horizontal. And so that means my vertices, we're going to use a for those vertices, and they're going to be located along that horizontal, along that x-axis. So they're going to be x values. So I'll have plus or minus a comma 0. My co-vertices would be for b, and those are going to be along the y-axis. So those are y values. So we'll have 0, comma, plus or minus b. And we should probably make a note here. Vertices is major axis. Co-vertices is minor axis. So now we're going to look at turning this around and having x squared over b squared plus y squared over a squared equals 1. So in this case, if my bigger number is with y, I'm going to have a vertical major axis. And so my vertices would still be connected to a. They're still going to be using a, but this time it's on the y-axis, their y values. So I'll have 0, comma, plus or minus a. This time my co-vertices are going to be on the x-axis, and those are still using the letter b, but they'll be plus or minus b, comma, 0. Something that you really will have to memorize is this is how I find the foci. I find the foci because they are c units from the center, where c squared equals a squared minus b squared. The way I remember how to sub things into this formula is that when I'm trying to work with a and b and remember which one's which, I always know I need to subtract them so that my c ends up being positive. And we'll look at that here in a little bit. For my first example, I'm going to take this equation, I'm going to write it in standard form, and then I'm going to go through and identify a bunch of information. So first I'm just going to write it out. 4y squared equals 100. If I need it to be equal to 1 instead, then I'm going to have to divide everything by 100. That means I'll have x squared over 4 plus y squared over 25 equals 1. So I kind of hinted at how we would graph these earlier. My x and y, there's no plus or minus anything with those, so my center is going to be at 0, 0. Now in the x direction, my x squared is over 4. Square root of 4 is 2. That means I need to make my ellipse go out 2 units from that center in both directions on that x-axis. So in that horizontal direction, I'm going 2 units to the right, 2 units to the left from my center. My y squared is over 25. Square root of 25 is 5. So in the y direction, so that means up and down, I'm going to be moving 5 units up and 5 units down. So now all I have to do is try to connect my ellipse. If you thought circles were hard, ellipses are even worse. And now I need to go through and identify this information. So once I graph, then I go through and find vertices. I'm supposed to find co-vertices also, and then we'll solve to find the foci. Co-vertices. So I know my vertices are going to be on that major axis. So I'll have a vertice here and a vertice here. Those are going to be my vertices. So because I haven't graphed, all I have to do is find their coordinates. So I have one at 0, 5, and then at 0, negative 5. So 0, comma, plus or minus 5. Now I need to find those co-vertices. The co-vertices are on my x-axis. I've got a co-vertice here and here because that's my shorter axis. And again, all I have to do is figure out their coordinates. It looks like 2, 0 and negative 2, 0. So plus or minus 2, 0. So now I need to find the foci. So I need to remember for foci, I need to figure out c, and c squared equals a squared minus b squared. So I want to point something out to you. I have a plus here, and I have a minus in my foci formula. And you'll understand why that's important for the next section that we do and the notes that we do. So I know I need to subtract a squared minus b squared so that I get something positive. And so I've got 4 and 25 as my a squared and b squared. So I'm going to write 25 minus 4. So again, I don't have to really worry about which one's a and which one's b. And that will give me 21. And so when I take the square root, I will get the absolute value of c equals plus or minus square root of 21. So I know that my foci lie on the major axis. And that they are C units from the center. So square root of 21 would be somewhere between 4 and 5. So that means I would have one of my foci up here, and I'd have one of my foci down here. So my foci lie within that ellipse. And you'll see why that's important tomorrow as well. So I had one of them went square root of 21 up, the other one went square root of 21 down. Square root of 21 down from that center. So that means my foci will be at, let's see, where are we at here? Oh, there's foci. So if there are y values, then it's going to be 0, comma, and then I'll have plus or minus square root of 21. For example 2, it says to write an equation of the ellipse that has a vertex at negative 7, 0, a co-vertex at 0, 4, and the center is at 0, 0. So they're giving us some information here. So when they tell me I have a vertex somewhere, that's giving me a clue about the major axis. When they say something about co-vertex, that's giving me a clue about the minor axis. So it says my major axis, the vertex is at negative 7, 0. So if my center is at 0, 0, and then negative 7 is really an x value, so I move negative 7 units from that center in the x direction, it's telling me my major axis is the x-axis. And over here, my minor axis, I can see 0, 4. This is a y value. Maybe we should label the y's and the x's. Since the 4 is that value where we've moved up or down 4 units, then the minor axis is going to be y. So in order to write the equation for an ellipse, I will have x squared over a number plus y squared over a number, and then it's going to equal 1. So if I know my major axis, I've got that negative 7, 0, then this number paired with x is going to be 7 squared, and with y, I'll have 4 squared. And maybe it would even help to look at a good graph right now. So this would be my 0, 0. It says I have a vertex at negative 7, 0. So that means my other one would be over here, right? It's symmetrical at positive 7, 0. I have a co-vertex at 0, 4. So that means the other one would be down here at 0, negative 4. So this would be my ellipse. And I know because I've moved out 7 units in both ways for the x direction, that the x is over 7 squared. And the y squared, because I've moved up 4 and down 4 units for that minor axis, the y squared is going to be over 4 squared. So now I just want to simplify my equation. I'll have x squared over 49 plus y squared over 16 equals 1. Example 3, marketing research shows that a hand lotion bottle with an elliptical base is easier to hold than a similar size bottle with a circular base. Write an equation of the ellipse, find the area of the base. So down here, I want to give you the area formula. The area is pi times AB. So what I kind of like about this is I'm thinking about area of a circle, and that's equal to pi r squared. So think about what A and B are in an ellipse. So I don't have that same radius all the way around, but in my bigger direction, I have A, and in my shorter direction, I have B. So instead of taking the radius and squaring it, we're multiplying A times B instead. So it's one of those formulas, if I really think about what it means, it kind of makes sense to me. So we want to write an equation of the ellipse. So we're going to center it at 0, 0. So I'll have x squared over a number squared plus y squared over a number squared again equals 1. So I kind of already labeled these a's and b's here. So in my x direction, if this whole width is 8, then I'm going 4 units to the right, 4 units to the left from the center. So x squared is going to be over 4 squared. In my y direction, if the whole length of this bottle, I don't know which I called length, which I called width now, but it's 6 centimeters. So that means 3 centimeters one way, 3 centimeters the other way. So y squared will be over 3 squared. So now I have x squared over 16 plus y squared over 9 equals 1. And then to find my area, I already gave you that area formula. So we're going to come up with pi AB. And we know that A and B, and here we could really interchange them, couldn't we? So my A is going to be 4, and my B is 3. So my area is going to be 12 pi. And if I was a manufacturing company, I probably would want to not know that the area is 12 pi. I would probably want to know an exact number. So we should go ahead and multiply 12 times pi in our calculators, and we would get about 37.7 centimeters squared. For example 4, we want to write an equation of an ellipse that has a vertex at 0, 10 and a focus at 0, 8. So this time I'm not given a vertex and a covertex. I have a vertex and a focus. So I want to be thinking about that focus formula that I have. C squared equals a squared minus b squared. And I'm also going to want to work with the standard equation of a circle. So I'll have x squared over a number squared plus y squared over a number squared equals 1. My center's at 0, 0 again, so nothing funny here. It's kind of stuff that we've been doing. My vertex, I have 0, 10. That's an x and a y. So they're giving me an x or a y value. That's the part that's changed. That means that my major axis is y. And that makes sense too. 0, 8, my focus is on my major axis. 8 is a y value as well. So that means in my formula over here, my major axis is going to be my a value because I have to have bigger number minus smaller number. So I'm going to use 10 for a. And because 8 is from the focus, that's going to be c. So I'm going to go ahead and substitute into my equation for the foci. And I'm going to solve and get this other value. So I already could fill in, I can't fill in the x, can I? I can fill in the y. The y-axis is going to be my major axis. That vertical axis will be major. And then this is going to be a 10 squared. I have to solve to figure out what goes underneath x squared. So c squared will be 8 squared equals, I know what a is. A is 10 squared minus b squared. I'm going to go ahead and do my squares. And then I would subtract 100 on both sides, which looks concerning because I get a negative number, but I have negative 36 equals negative b squared. So then 36 is b squared. Square root both sides. I do have an absolute value here. It makes sense to have that absolute value. So plus or minus 6 will be equal to b. So I know that this is for my minor axis, which I know is actually the horizontal axis. And so I have x squared over 6 squared. And I want to simplify. X squared over 36 plus y squared over 100 is equal to 1. There are lots of other great videos out there on watching ellipses. If you're still confused, reach out to your teacher, check out some videos on Khan Academy. Please let us know if you need help.